Okay, I'll be sharing slide right here. So can everyone see the screen? Okay. Yeah. Okay, then we can start with this question. So number 6, I think this was a graphing question. So Adamu was traveling a distance of 40 kilometers from Kadungu to Datan. And 60 minutes after starting the journey, he made a stop at Kultown, which is 10 kilometers from Kadungu, to rest for 30 minutes. He then continued the journey from Kultown and reached Datan 60 minutes later. It says using a scale of 2 centimeters to 20 minutes on the horizontal axis and 2 centimeters to 5 kilometers on the vertical axis, draw a distance time graph for Adamu's journey. Okay, so the question is asking us to make a sort of graph. And to make this graph, we need to clearly set the distance and the time between the towns. So what did it say here? So the total distance is 40 kilometers. So, from here, Karongu, all the way to Datnu. That is 40 kilometers, right? 40 kilometers. From here to all the way here. And then it said 60 minutes after he made a stop at Kultown in the middle. So 60 minutes. And it says 10 kilometers from Karungu. It's 10 kilometers is the distance from Kadungu to Kultown. And then it says rest for 30 minutes. Just here. 30 minutes. He then continued the journey from Kultown and reached Datan 60 minutes later. So 60 minutes is here. And we got 30 kilometers here because we know the total distance is 40 kilometers. But Adamu already walked 10 kilometers. So he has 30 kilometers left to walk. So yeah, we get 30 kilometers here. So using this information, we can draw the graph. So here, the horizontal axis is the time, and the vertical axis is distance. This distance right here, and time under here. It says 2 centimeters for 20 minutes. So we know here, 1, 2. If we say that this distance is 1 centimeter, and see this is 1 centimeter. Then these two
And these two
must be 2 centimeters.
two centimeters.
One, two. And that is equal to
And
20
that is
minutes.
equal to 20.
That's the scale
That's the speed.
you're going to draw the
You're
graph
going
with.
to draw the graph.
And then two
And then
centimeters
2 centimeters,
for 5 kilometers
5 kilometers.
of distance. So one,
So 1,
two,
2,
and this much
this
is
much
5 kilometers.
is.
So we can draw the
So
graph.
we can draw the graph.
So we can draw the
We can
scale
draw the scale.
at the bottom here.
Here.
So every
So
two
every 2
jumps here,
jumps here,
you get 20 minutes.
you get 20 minutes.
So 20,
20,
40,
40,
and then 60.
and 60.
From Kadungu
From
to cool down,
Kadogu to
it
cool
takes
down,
60 minutes.
60 minutes.
That's why it's over
That's
here.
why it's over here.
And the distance was
And the
10
distance is
kilometers,
10
right? It's 2 centimeters to 5
centimeters to
kilometers.
5.
So
So
1, 2
1,
centimeters.
2
This is
centimeters,
5.
5.
And then
And
1,
then
2.
1
This is 10
is 10.
kilometers. So that's why we
So
draw
that's
from
why
this
we
point
draw this point
to this point.
to this point.
See, 60
Is
and
60
10.
and
60 minutes to get
60
10
minutes to get
kilometers
10
to Cool Town.
kilometers.
And then it said
And it said,
Adamu rested
oh,
and
rested.
cooled down for 30 minutes. If he
If
rests
he
20
rests
minutes, 30 minutes,
30 minutes,
does the distance
does the
change?
distance change?
See here, it
Here,
it doesn't, right?
it
The
doesn't,
distance
right?
doesn't
The
change
distance doesn't change.
because he didn't
Because
move.
he didn't move,
He just rested.
just
So
rested. So
that's why we draw a
when we draw
horizontal line
horizontal line,
for 30 minutes.
30 minutes.
How many
How
centimeters
many centimeters
on the graph is
on
30
the
minutes? Um, answer is like if 2 centimeters is
2 centimeters
20 minutes,
20 minutes?
then
And
1, 2,
1, 2,
3
3
centimeters should be 30 minutes.
30 minutes.
Right? That's why we go from
That's why we
here
go from here,
and then 1, 2,
1,
3.
2, 3.
And then we're rested for
And
30
we
minutes
rested for 30
in Cool Town.
in Cool Town.
And then finally,
And then
from
finally,
Cool Town
from Cool Town
to Datanu
to Datanu
takes 60 minutes.
takes 60 minutes.
So we need to
So we need to
go
go
here.
here,
6 centimeters
6 centimeters
in the horizontal
in the
axis.
horizontal.
Let's count. So
Let's count.
1,
So
2,
1,
3,
2,
4,
3,
5, 6.
5, 6.
Sits over here in this line,
It's over here in this line.
which is right.
Which is right.
And then he traveled
And then
another
he
30
traveled
kilometers.
30 kilometers.
And we know 2 centimeters is
And
5
2
kilometers.
centimeters is 5.
How many
How
centimeters
many centimeters
on the graph will be
on the
30
graph will be
kilometers?
30 kilometers?
So from here
So from here
all the way to here.
all the way to here.
Yeah, it'll then be
It'll then be
12 centimeters, right? Because 5 times
5 times
6 is
6
30,
is 30.
and 2 times 6 is
And
12.
2 times 6 is 12.
So when you are drawing this
So when you
graph,
are drawing this graph,
you need to count the
you need to
distance in
count the
centimeters.
distance instead.
Okay, so let's count 12
So
up.
let's count
1,
12 up.
2, 3,
1,
4,
2,
5, 6, 7, 8,
7,
9, 10, 11, 12.
11,
Yeah, exactly right here.
exactly right here.
That's why we draw
That's when
from
we
this point
draw this
in Cool Town
in Cool Town
all the way to
all the
Datanu,
way
which
to
is here.
Datanu.
So that is how we
So that is
draw
how
a
we,
graph based on this scale.
based on this scale.
Okay, nice.
Okay,
So
nice. So
we can move on to the next
we can move on
part
to
of
the
the
next.
question. So is everything about this
Is
clear
everything
for
about this
everyone?
clear?
Do you have any questions
Do
about
you have
this?
any questions about this?
Yeah, if you don't have any
Yeah,
questions,
if
we
you
can
don't have any questions,
look at this one.
look at this one.
Okay, now we're using the graph
Okay, now we're using the graph
to answer these questions.
to answer these questions.
So number one is the
So
distance
number
from
one is
Cool
the
Town to
distance
Datanu.
from Cool Town to Delta.
Can you find the
Can you
distance?
find the distance?
Yeah, so
Yeah, so
distance
distance
from Cool Town to
from
Datanu
Cool Town
is, you can see
to
Datanu is 40
Delta.
kilometers away and Cool Town is in
And Cool
10.
Town.
So it is simply
So
40 minus 10, which is 30. So Cool Town and Datanu, 30 kilometers away. That's the distance.
that's
And can you
the
calculate the total time
total
taken by Adamu
taken by
to make a whole journey, including the rest time?
including the rest.
So what is the total time?
Well,
Yes, that's right.
yes, that's right.
Is it 150 minutes? That's right. Because you can
Because
see from here,
here
it stretches to here, right?
here.
That is between 140 and 160. That is 150. Yeah. And then we can use the past information too. From Kadungu to Cool Town, it took 60 minutes. And then he rested for 30 minutes and took another 60 minutes to get to Daotanu. So that is 150 minutes in total. Okay. Number 3, calculate the average speed of Adamu from Cool Town to Daotanu. So we're finding the speed. Do you know how to calculate the speed from the graph? Yeah, let's see. So to calculate the average speed, we take the time and the distance. So it'll be distance over time. We know that it took 60 minutes from Datanu to get from Cool Town. Sorry, for Adamo to get from Cool Town to Datanu, right? And then it took 30 kilometers to get to Datanu. So speed is distance over time, right? So it'll be 30 kilometers over 60 minutes. And that would be 1 over 2 or half kilometers per minute. That will be the average speed from Cool Town to Datanu. Does this make sense to everyone? Do you have any questions about any of these questions? So everything's clear about finding the speed of this. So it is always um, distance over time equals speed. Right? That's why I divided 30 kilometers by 60 minutes. And speed here is the same thing as slope in a graph. So we're finding the slope over here. The slope
Yes. Slope
is change in
is
y over change in x. That's what we did here to find the speed. Okay. Um, if you have any questions, always feel free to ask. Um, but I think this is the last question for 2025 BEC. And we will actually move on to the 2024 exam and start from the beginning here. So, yeah, let's get started then. All right. Let's look at this first question together. Two brands of air conditioners, S and T, costs 3,000 and 4,000 Ghana cedis, respectively. A company budgeted 20,000 cedis to buy air conditioners. If the company bought 5 units of brand S instead of brand T, how much did it save? Oh, yeah, did you say B? Okay. Yeah, if you said B, then that is correct. Okay, I'll get into why. So we know that brand S costs 3,000 cedis and brand T costs 4,000 cedis. So each time they buy brand S instead of brand T, they save 1,000 cedis. So because 4,000 minus 3,000 is 1,000. But they bought 5 S units. So they didn't just save 1,000, they saved 1,000 5 times. That's why they saved 5,000 cedis in total. Or you can calculate it in a different way. So you can first multiply 5 units for both S and T and then subtract. So if they bought 5 brand S, 3,000 times 5 is 15,000. 4,000 times 5 is 20,000.
20,000.
What is
What is
20,000
20,000
minus 15,000?
minus 15,000?
That is 5,000.
That is 5,000.
That's why the answer
That's
is
why the answer is
5,000
5,000.
Ghana cedis. Okay. Does this make sense to everyone? Do you have any questions? Okay. Yeah, I hope this is clear for everyone. Okay, let's move on to the second question. So Zalia and Amina shared an amount of money and the ratio 2 to 5. If Amina had 150 Ghana cedis more than Zalia, how much did they share? So we're finding how much total money they had. If their ratio was 2 to 5, and Amina had 150 more than Zalia, how do we find this? Okay, so this one is can be a little difficult because we're using a ratio, right? So whenever you see a ratio, we need to know that we need to set up and cross multiply. So, and then we also know that Amina had 150 cedis more than Zalia. We don't know how much Amina or Zalia had. We only know that Amina had 150 cedis more than Zalia. So what we can do is we can let X be equal to Zalia's share. X is Zalia's money. So what is Amina's money? So Amina's money is X plus 150. Because Amina had 150 more than Zalia, right? X plus 150 is Amina. And then we know the ratio between Zalia and Amina is 2 to 5. So we set up the ratio. X to x plus 150 is equal to 2 to 5. Does this make sense for everyone? This is the ratio, right? So Zalia's share, x, to Amina's share, x plus 150. That is equal to 2 to 5. And then we cross multiply. Cross multiply means you multiply this inner side and then you multiply this outer side. Can you see this? Multiply this inner side, multiply by this outer side. Okay. That's what we did here. 5 times x is equal to 2 times x plus 150. We cross multiplied, set them equal. And we know that this is 5x. 5x is equal to 2x plus 300, right? We subtract x from both sides, 2x from both sides, and we get 3x is equal to 300. So x is equal to 100. Right? If we divide by 3, x is equal to 300 divided by 3, which is 100. And 100 is equal to x, which is Zalia's share. You know? This is Zalia's share, 100. What is Amina's share? Amina's share, remember, is 100 plus 150. Amina had 150 more than Zalia. So she had 250 Ghana cedis. That's Amina's share. But what is the total share? The question is asking, how much did they share together? So we add the numbers, right? Zalia's share, 100, plus Amina's share, 250. Does that equal? $350, right? 350 cedis. That's why the answer is D, 350 cedis.
Recording in progress.
So I will go through this one more time. So we were looking at this question where Zalia and Amina shared the money in the ratio 2 to 5. And it said, if Amina had 150 more than Zalia, how much did they share in total? So we started by setting X as Zalia's share, and Amina's share was X plus 150 because Amina had 150 more cedis than Zalia. And then the ratio from Zalia to Amina is 2 to 5. So X to X plus 150 is equal to 2 to 5. Everyone see this? And then what we can do next is cross multiply. Cross multiply means multiplying this inner side, x plus 150, with 2, and then multiplying x by 5. And then set them equal to each other, right? So the equation becomes 5x is equal to 2 times x plus 150. So can you solve for the x here?
But can you solve for the x here?
Yeah. Yeah, so x is going to be 100, right? And 100 is Zalia's share. And Amina's share is 100 plus 150, which is 250. And their total share is, you have to add these together, right? 250 plus 100, and what is that? It's 350, right? So they will have a total of 350 Ghana cedis. Now this ratio part might be a little confusing. So we set up the ratio because we knew that Zalia and Amina, Zalia to Amina was 2 to 5, right? And we can let that equal to Zalia to Amina with respect to this right here, x. So x is Zalia, x to x plus 150 is equal to 2 to 5. Let's have another example of the ratio. So let's say, I'll put it over here. So 1 to 2 should be equal to, let's say, 2 to what? Let's say x. Can you find the x here? This is like a ratio, right? Yes, can you find the x here? What is x? Yes, that's right. X is equal to 4. Yeah, great. So x is equal to 4. And we can solve this by cross multiplying. Do you remember the cross multiplying method? So here you multiply like this cross. So x is equal to 2 times 2, which is 4. And you need to know that this ratio is equal to the fraction, so you can convert it anytime. So this is the same as what we did here. So what we did was 1 to 2 is equal to 2 to x. That's what we did here. This is equal to this case right here. That's why we cross multiplied, right? Cross multiplied. Multiply this one and multiply this one and equal it. Yeah, so let's have can just one more question before we move on. So 3 to 5 is equal to 15 to x. Can you find the x here? Yeah.
Give me 25.
Yes, can you say that again, please? Yeah.
Give me 25.
Yeah, that's right. It's 25. Great job. Yeah, it's because we see that 3 times x is equal to 5 times 15, right? We multiply instead of equal, right? So we divide by 3. So x is equal to, what is 5 times 15? It is 65, right? Sorry, 75, right? Over 3. So you divide by 3. And that is equal to 25, right? That's how you find x. And always remember that ratio is equal to fractions. So you can put it in this way as well. So 3 over 5 equals 15 over x. You can put it this way as well. This is the same as this ratio. So you can solve it this way too. We know that we multiply 5 on the numerator to get 15. You can multiply 5 on the denominator to get x. This is the same way. You get x equals 25 again this way as well. Yeah, so this was the ratio problem. And yeah, I hope this makes sense for everyone. You can convert um, ratios into fractions, or you can always let this cross multiplication method to find x as well. Yeah, did you guys understand everything for this problem? Or yeah, if so, I can move on to the next question. Okay. Yeah, okay. Let's look at question number 3. So, which of the following example is an example of quantitative data? So, not qualitative, but quantitative. Yeah, that's right. The answer is D for this one, because quantitative data is a sort of numerical data that can be measured or counted. So, examples are like height, time, and length as well. But A, B, and C are qualitative data. So qualitative data cannot be measured or counted. So colors cannot be measured, right? And cannot be counted. Gender cannot be counted as well. And material status also cannot be counted. They are called qualitative data, not quantitative. So yeah, the answer is D for this one. But let's look at more examples about quantitative versus qualitative, because this is quite important. So, what type of data is blood type? Is this qualitative or quantitative data? Yeah, so blood type, what I mean by blood type is there are blood types A, you can have a blood type A, you can have a blood type B, or you can have O or AB as well. So is this um, quantitative or qualitative data? Can these be counted really? Are these counted by numbers? No, right? We cannot count blood type by number. So what would that be? That would be qualitative data, right? That would be qualitative, right? Because blood types are only of A, B, O, and AB. They are not numbers and they cannot be counted. That's why blood type is qualitative data. Yeah, let's look at question 2. So what type of data do you think is body weight?
Quantitative data.
Oh, yeah, good job. It's quantitative data. Yeah, that's right. Because you can measure body weight by number, right? You can be like 30 kilogram, 40 kilogram. You can measure by numbers, right? And 50 kilograms, you can measure by number. So that's why body weight is quantitative data. So that's the difference between qualitative and quantitative data. Okay. Let's move on to the next question for now. Okay. Question number 4. In the diagram here, P and Q are two sets, and U is the universal set. Use the information to answer the question below. Question 1 says, find P intersection Q. And I'm going to make this a little bigger. Um, okay, so I hope you can see the diagram on the right here. And we are finding P intersection Q. And intersection means, yeah, it can be found in both sets. Yeah, so did you say which one? A or A, right? Yeah. Yeah, do you say we cannot see the diagram or um okay, I'll try to um, yeah. So here, yeah, we're looking at P intersection Q. So what is in both P and Q for this? What letters? Yeah, let's look at these together. What's in both P and Q? So what about, so are you saying A is an intersection? It's only inside P, and that's not in Q, right? Same with B. B is in P, but not in Q? What is in both P? What is in both P and Q? So P intersection Q. So only letters are C, D, and E. These three letters are the only ones that are inside both Q and P. Right? And F, G, and H are completely outside the set. So let's go back to this question. So it says to find P intersection Q. And we know it had C, D, and E. So yeah, we see it here. It's C, D, and E, right? That was P intersection Q. So that's why the answer is A for this question. A. Because C, D, and E are in both P and Q set. Okay. Let's look at number 5 really quickly. So, how many members are in set Q? So, how many are in Q? Yeah, so what are the members of set Q? Yeah, so member is something inside the set, right? So the members of Q, what are the members of Q? This circle is Q, right? This circle is Q, and inside Q, there are only 3 elements, right? C, D, and E. These are the only 3 members of the set Q. Okay, now, what are the members for set P? What is inside this whole circle? Yeah, so it'll be A, B, C, D, E, right? All of these are inside the set P. This is the set P. What about the set U, for example? Set U, this whole rectangle. What are the members of set U? These are. So it's all, right? So A, B, C, D, E, F, G, H. All of these are inside set U, right? All of these are inside the set U. So all of these are members of set U. Another way to represent this is by using this notation here. This notation means a set right here. If you set a bracket and you say C, D, and E, and then you say Q is equal to this set, right? And these are the three elements that are inside Q. So the answer for 5 is 3 elements. Since we have C, D, and E, those are 3 elements. And yeah, a set here I've defined is a collection of things. So set is everything that is contained in. And a member or an element is something that is inside the set. So members of a set, Q, are C, D, and E. Right? Those are the members of set Q. Now, a subset of set Q means any set that is within the set Q. So it's different from members. The subset is not equal to members. If you're wondering what a subset is whatever set is inside Q. So for example, the subset of Q can be C, D. This can be a subset. The subset can be C, E. The subset can be D, E. Subset can even be just one element, like C can be a subset. And then D can also be a subset. E alone can also be a subset. So CDE can be also a subset of Q. And nothing inside the set is also a subset of set Q. So subset is the set that can be formed by the members inside the set Q. Any combination of C, D, and E. Does this make sense for everyone? Like, what is considered a set? What is a member? And what is a subset? Do you have any questions about this? Or do you want me to explain more on something? Or
Any question? Okay. How many questions?
oh, no questions? Oh, okay. Yeah, I hope this makes sense for everyone. Just know that this question was asking for members in a set, right? Yeah. And then an intersection, which you need to know that intersection is what is found in both sets. Okay. Let's move on to the next question. Amadou walked to a point such that he is always the same distance from two villages, P and Q. Which of the following best describes the locus of Amadu. Locus is a place or a set of points. So what describes the point where Amadu is? So what is this place called where distance from P and Q are the same? So oh, did you say C? Um, so C, the straight line from P to Q. So P to straight line is just this, right? And Amadu is not really in a straight line, right? That doesn't describe the position of Amadu. So Amadu is actually over here, right? Amadu is here. And then the distance from P to Amadu is A, and Q to Amadu is B. But A is equal to B in this case, right? So what we call this point is called perpendicular bisector of the line PQ. I will explain this on the next slide. So you might be wondering, what does a perpendicular bisector mean? So what does that mean? Yeah. Perpendicular, well, that means forming 90 degrees. For example, this straight line and this straight line are called perpendicular. Why? Because it forms a 90 degree. These two lines are perpendicular. Bisector, what does bisector mean? Bisector means dividing the side by the same length. So if we have this much, and we say over here, if the line crosses like this, and this length is equal to this length on the right, then this line is called a bisector. It divides the line into two equal lengths. So perpendicular bisector, all it means is that it is dividing this PQ into two equal lengths in 90 degrees, right? It forms a 90 degrees with PQ, with this line PQ. And then it divides by the same length. These two are the same length. That's a bisector. So where Amadu is called a perpendicular bisector. So yeah. Amadu's perpendicular bisector is lined all the way here. So it's just cutting this line, right? And then from any distance, A and B, this holds true. If Amadu is over here, Amadu is over here. What about this case? Then this lengths are also equal, these lengths. Right? If Amadu is here, what is that? This length and this length are equal. Right? I'll show a better example on the next slide. Here, the next slide shows this example. Can everyone see this? Yes, okay. So the first slide up on top, this is called the perpendicular bisector of the line segment. So here you can see that this line, AB, is 90 degrees from PQ, right? This is 90 degrees. That's perpendicular. And it divides PQ into two equal lengths. Okay, so if this line is all the way stretching from PQ, so here, this line all the way stretches, this perpendicular bisector stretches infinitely to the top and to the bottom. So any point that is on here would have these two lines equal. So the distance between X and Y would be equal. So point here has this distance from X equal this distance from Y. Point B is also this point B is also on the perpendicular bisector. So this distance is equal to this distance right here. And point C is also on the perpendicular bisector, right? This point. That means this distance from X to C is equal to this distance from Y to C. That is just the property of perpendicular bisectors. Any point that lies on the perpendicular bisector has two equal lengths from the side. Yeah, does this make sense to everyone? This idea of perpendicular bisector. So Adamu was at a point where X and Y are always equal. And you can see Adamu is always on this perpendicular bisector line. Always on here. Because on a perpendicular bisector, the side lengths are always equal to each other. The other options were an arc passing through PQ. And here, option A was actually arc passing through PQ. And the other option was circle passing through PQ. So what does that mean? I've shown here. An arc passing through PQ would be like this, right? It's an arc. And if this line is PQ, this is the arc. And a circle passing through PQ would be if a PQ is over here, then the circle is around PQ. So this is an example of an arc passing through PQ and circle passing through PQ. So that is why the answer is D for this question, perpendicular bisector. And I hope you understand what a perpendicular bisector is. So yeah, so Amadou is in this perpendicular bisector. A is always equal to B. A is always equal to B. Okay. So I will have to finish up here. This was the last question for today, but do you have any questions for me today? Any questions about any of the problems that we solved? Yes.
Please, can you go to the first line so that we can copy it?
Hello.
Yes. So which slide do you want me to go to? The first slide? This one or which one?
Adam.
Oh, the Adam question.
Yes. This one. Yeah, then Adam.
This one, Amadou? Yeah, this one. Or you mean this one?
Yeah, graph question.
Sorry, which one? Do you mean this slide or yeah?
The graph one. The graph one.
Oh, the graph one?
Yes.
Is it this one or is it
No.
this one?
The graph. No, not this one.
Oh, not this one or oh, the graph one, the 2025 one. Oh, sorry.
Yeah.
You mean
Yeah.
this one? Okay. Yes. Can you see the graph? Okay. Yeah. I'll let you copy and yeah, this is how you would draw the graph.
Jamie, please, we want the main question.
Sorry, you said more. Is this one before this one too?
One day Adamu was traveling.
You mean like this question you want to copy?
Yeah, this one.
Okay, yeah, you can write down this question and you can draw the graph after. Yeah.
Okay. Yeah.
Yeah. Do you need more time to copy this slide or
Let me please react that.
Oh, okay. If you're done,
Yeah.
did you did you draw this graph or
No, you should draw down.
you don't have to draw all this, but I will share you the slides after as well. So I can or if you want to, you can draw these as well. But yeah. But did you have any other questions for today? Or oh, you said, are you finished with this one? Oh, okay. All right. I think that was the end for the graph question. So, did you have anything else that you wanted to talk about or yeah, if you don't have any questions, then I think we can continue next week then.
Okay.
Uh-huh.
Thank you very much.
Okay, yeah, thank you for listening. And I will share you the slides for the 2025, yeah, mathematics.
Okay.
And okay. Yeah, I'll see you next week then. For more mathematics.
Yes, sir.
All right.
Okay.
Yeah. Thank
Bye-bye.
you. Bye. Bye everyone. Yeah. Bye everyone. See you next week. Mhm.